The following is the video solution from JSDT Solutions. Question 8 says, in the diagram below, T is the hook on the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane from where three people are observing the hook at T. Okay, the angle of elevation from Q to T is X, that's over there. And we are given that angle QSR is 90 degrees plus X, angle QRS is equal to X, and QR is 5 units, and TS is equal to SQ. Okay, and the first question is to prove that QS is equal to 5 tan X. Okay, so notice that with QS, it has 5, which we could see 5 is the side QR, and it has tan X, so it's in reference to X, it's in relation to X. So they've clearly used this triangle down here. So this is a case where we don't really have any right angle triangles, so we're not using trig ratios. Okay, let's see how we can find QS. Using this triangle that we have below here, QS is this side here. To find this side, we can focus on using the sine rule just because of the angles that we have here as well. So the angle opposite QS is X. And then we also have another paired angle and side that is complete here. We have 5 units, and opposite 5 units, we have 90 degrees plus X. So let's go ahead and use the sine rule. So the sine rule, but we'll make QS the subject, the side the subject. So we're saying QS over sine of the angle opposite it, which is that angle X over there, is equal to, and you have to follow the same order. If we said side over sine angle, we also need to say side, which is this 5, over sine of the angle. So that is sine of 90 degrees plus X. And all we have to do here is make QS the subject of our equation. So QS would be equal to, you could multiply both hand sides by sine X to get that over there. So we're really just transposing it. And so that is going to be 5 sine X, because when it multiplies, it ends up in the numerator. Okay, so this is equal to 5 sine X all over sine 90 degrees plus X. That's a cofunction. So it simplifies to cos X. And there, that's where the tan comes from. So QS is simply equal to 5 tan X because of sine X over cos X. And that is our answer. Question 8.2 says, prove that the length of QT is 10 sine X. So let's see, QT. Now that we have this as 5 tan X, then how do we find QT? Well, there's also other things that we know here. Because QS and ST are equal, then this is also 5 tan X. So using the information we have, how do we find QT? Okay, we could also use the sine rule here just because of the relationship between the sides and the angles opposite it. So we've got 2 sides in this triangle, but we also have an angle. Okay, we have an angle, and this one pair is complete. You've got an angle and you have a side opposite the angle. So that pair is complete. Now to find QT, we simply need to find the angle opposite QT, which is this angle over here, QST. And we can find this since these 2 sides are equal. We have an isosceles triangle. So if this is equal to X, then this angle over here is also equal to X because of the isosceles triangle. So we can tell them that firstly, QTS is also equal to X. So angle QTS is equal to X because we have an isosceles triangle. And so because of that, we can find this center angle over here, QST. We'll find that by saying 180 degrees minus X, which is 180 degrees minus 2X. So that angle QST, is simply equal to 180 degrees minus 2X using the sum of angles in a triangle. So that's what this is, 180 degrees minus 2X. And now we can finally find QT because we have the angle opposite it. So we're using QT and the angle opposite it. So we'll say QT over sine of the angle opposite, which is 180 degrees minus 2x. That's QT over sine 180 degrees minus 2x. And this will be equal to, we'll take another pair that is complete. And the other pair that we have complete is these, well, both are complete really because they both have 5 tan x. So you can just pick one. We can just go ahead and take this. So we'll take in 5 tan x as the side opposite sine x as the angle. Okay, so that's 5 tan x over sine x. And now we can just go ahead and multiply both hand sides by that denominator so that we can leave QT there. So it's like transposing this from the denominator, it will move to the numerator. So QT is equal to, we have 5 tan x, and this is multiplied by sine 180 degrees minus 2x, and this goes all over sine x. Okay, so let's simplify. QT is simply equal to, we can use the identity of tan x, so that's going to be 5 multiplied by, that is sine x over cos x, and this is multiplied by, when we simplify that using the reduction, you see that it is in sine's quadrant, 180 degrees minus an angle. Okay, so this will reduce to sine of that angle, 2x, and this goes all over sine x. Okay, at this point you can cancel out these two in the numerator, but here's another thing we could do just to make this look more simple. We're saying 5 multiplied by, and let's just say that was still left the same. It was still sine x over cos x. Then we could use the double angle identity for sine 2x, which is 2 sine x cos x, and this goes all over sine x. Okay, and now you see that sine x and sine x will cancel here, and now you're left with, in the numerator you have sine x over cos x multiplied by cos x. This cos x, right, despite the fact that they're all in the numerator, this cos x is in the numerator as in it has a denominator of 1. So it will cancel with this cos x in the denominator. And all we have left is that QT is simply equal to, we have 5 multiplied by 2, which is 10. And then the only thing left in the numerator is the sine x. So 10 sine x, just like they said QT would be equal to. So QT is equal to 10 sine x. Moving on to the next question. Question 8.3 says, calculate the area of triangle TQR if TQR is equal to 70 degrees and x equals 25 degrees. So let's look at that triangle TQR. Okay, just remember that we just found QT. That is now 10 sine x. And they want us to find the area of triangle TQR. And they give us the angle TQR, this angle over here. That is 70 degrees. Okay, so you see that we can use the area rule here. We've got the middle angle. We have a side next to that middle angle and another side next to the middle. And what it's going to look like is that the area of triangle TQR is simply equal to a half multiplied by the side QT. We can just write it down in full first. That's QT multiplied by the other side QR, which we know is 5 units, and then sine of that center angle, which they told us the size of, okay, which is that angle TQR again. So that's what our formula would look like. Okay, so this is equal to a half multiplied by QT, which is 10 sine x, and multiplied by QR, which is 5 units, and then sine of this angle, which we know is 70 degrees. Okay, so we're just going to substitute where necessary. So in place of x, we can substitute 25 degrees because they told us that already. Okay, so it looks like that. And then finally, let's just find that answer. And that area is equal to 9.0 and that's going to round up. So adding a 1 to the 2 there. So that is 0.93 units squared. And that is the area of triangle TQR. And that is it for question 8.